In the last video, we learned how to set up everything we need to start hacking the Ethernaut smart contract. Before starting this level, you should have your test Ethereum in your wallet, and you should have an instance of the Ethernaut level we're playing ready for you to go. Now you're ready to hack a smart contract. So we can see the level has two objectives. First, we need to claim ownership of the contract, and second, we need to reduce the balance to 0. Now let's look at the code and see where we can claim ownership of the contract. So we can immediately see at the top of the contract there is a state variable for an address of the owner. Since it's stored in the state of the application, we don't need to pay a gas fee to retrieve it. So let's call it using our console to see who owns this contract now. Go to your console and type in the command you can see on the screen now. We're using the await operator because this is an asynchronous call. We're making a request to the contract and we're waiting for a response. Once you hit enter, the contract will return the address of the person who is the owner. But if you type player, you'll see your address, and our goal now is to hack this contract to make the owner variable into our address, so we become the owner. The next block of code contains the constructor. Now the constructor is a function that will only run once when the contract is first deployed to the blockchain. We can see in this constructor, the owner is defined as the message sender, a message sender being the person who is sending the transaction to the contract. So for the purposes of the constructor, the owner will become the person who is deploying the contract. Next, we have a modifier. Now a modifier is called alongside a function to change the characteristics of that function. In this case, the modifier is called onlyOwner, and we can see that as part of the modifier, it requires that the message sender is the owner, meaning that when this modifier is used on a function, only the owner of the contract can call that function. If we scroll a bit further down past the contribute and the get contribution functions, we can see the withdraw function which actually has the onlyOwner modifier attached to it. Now this means that the only person who can call the withdraw function, which empties the balance to 0, is the owner. So now we know once we become the owner of the contract, we can call the withdraw function to satisfy objective 2, which is to make the balance of the contract 0. Now let's get back to finding out how we can actually become the owner. Now I can already see that under the function called contribute, there is a way for us to become the owner. This requires that we contribute more to the contract than the owner has done. If we satisfy that, we then become the owner of the contract. While this is possible, it's not the most practical way. Let's scroll down to the last few lines of code and I'll show you why. Here we can see a fallback function called receive. Now a fallback function is called whenever no other function has been called within the contract, but Ethereum has been sent. So receive requires that the message value is more than 0 and that the contributions of the message sender are more than 0. If both of these are true, then the owner becomes the message sender. So we already know we can send a message with a value of more than 0, but let's see how we can increase our contributions above 0. If we scroll back up to the contribute function, we can see there is a way for us to send value into that function, and that value will get added to our contributions under our address. So let's try that. Open up your console and type in await contract.contribute and then pass in a value of 1. Since you're changing the state of the blockchain by sending Ethereum, you will need to pay a transaction fee. Once that's done, open up your console and type await contract.getContribution to check your new updated contributions. Click the arrow on the left to expand the array, and if you've done it right, you should see the number 1 underneath words. So we've made our first contribution to this smart contract, meaning that our contributions are now above 0. This means we can now call the receive fallback function because our contributions are more than 0, and we can send a message value of more than 0. So now we just need to call the receive fallback function. To do this, we're just going to send a transaction to the contract. Open up your console and type await contract.sendTransaction and pass in a value of 1. So what we're doing here is we're sending a transaction with a value of 1, and our contributions at the same time are more than 0. So we satisfy both the requirements for us to become the owner of the contract. Once you've confirmed the transaction with MetaMask, run the contract owner command and the player command again. If they're the same, congratulations, you've just hacked your first Solidity smart contract. Party time! Hold on, that was just objective 1. We're now the owner of the contract, but we still need to make the balance 0. And if you remember from earlier, there is a specific function we can call within the contract as the owner that will pull the entire balance off into our own wallet. And that function is withdraw. So, open up your console and type in await contract.withdraw. Pay the transaction fee and wait for the transaction to be mined. If that got mined without any errors, then you've just emptied the entire balance of this smart contract into your own wallet.
Very cool.
Let's check the balance of the smart contract to be sure. Type in await, get balance, and in brackets pass in instance to check the balance of the instance of the contract you've deployed to hack into. And if it says 0, you've then satisfied objective 2 to pass this test. Scroll back up to the top of the contract, and now you're ready to hit Submit Instance. This will send the contract that you've hacked back to Ethernaut. The Ethernaut application will automatically check if you've met both the objectives, and if you have, you'll be passed.
Party time!
So what are the key lessons from this challenge? First, we know not to leave the owner variable open to attack by letting it be defined outside of the constructor. And secondly, we need to be careful of functions that aren't actually defined. You might have some code in there that you think is safe and can't be called, but then when it's a fallback function, you might find out that it actually can. I hope you found that useful. In the next video, we're doing level 2 of Ethernaut, which is also really interesting. So I'll see you there.